All right, so Matthew decides that he wants to go fishing this Saturday. So he, of course, his grandpa taught him, yes. Then you'll have to get it over there. His grandpa taught him that you should always go fishing very early in the morning. But he has gotten up every morning very early, and he decides, hey, I'm tired. I don't want to. Somebody ate one. Two halves? All right. Then that was my fault. But I did put 4. All right. So Matthew decides not to get up early. He does not want to get up early. It's not a school day. He's going to get up when he gets up, and he does. And around 11, 12 o'clock, he decides to go fishing, and he begins to cast and can't catch anything. He waits for a while and nothing. Nothing. He doesn't catch anything. Then finally, around 4 o'clock, he gets tired and he goes home. Today, we're going to find out why
Here we go again.
What are you doing? Okay, so today we're going to find out. Today we're going to find out why Matthew was so unwise to do what he did. He should have listened to his grandfather. He should have gotten up early. How does oxygen solubility differ from ionic solid solubility? Well, let's look at a typical example, which is salt, right? We've all allowed salt to dissolve in water at 24 degrees Celsius, which is around normal temperature for room water. You can dissolve 37 grams of sodium chloride. You can only dissolve 9 milligrams of oxygen. That's 9 1,000ths of a gram. That is huge difference. Why? Why is oxygen solubility so important to water life? Well, have you ever seen a fish come up to the surface, Matthew, and breathe in order to breathe? No, you haven't. Fish do not breathe air. Fish breathe oxygen. And here's the problem. The warmer the water gets, the less oxygen will be found in the water. The more dangerous it's going to get for the little fishy to be moving around. And that gives you a clue, Matthew, as to why you did not succeed. You waited too long. The water gets hot, less oxygen. Less oxygen makes it just very difficult for the fish to do what fishies do. Check it out. I think all your solubility curves that we messed around with, they were all going up. All the solubility curves went up. For gases, they go down. Gases become less soluble as the temperature increases. So, how do gases behave in water? As the water temperature increases, they become less and less soluble. Less and less soluble. About how many times more soluble in water is oxygen gas at 0 degrees C than water at room temperature of 25 degrees Celsius at 0, where water is very, very cold? You'll find twice as much oxygen as you would at room temperature water. Watch this. We're going to actually do this lab. It's interesting. You have three types of water. On the left, you have very cold water. It looks cloudy, but it's actually not. It's just full of condensation. In the middle, you have room temperature water, and then this cloudy stuff over here is hot water. What makes Coke fun for you to drink is that it's refreshing, it's cool. The reason why it's cool and refreshing is because of the little bubbles. There's gases dissolved in your Coke. Notice what happens to these gases over time. In the cold water on the left, some of it has come out. In the room temperature, in the middle, some of it has come out. In the hot water, a lot of it has come out. Now, some time is going to pass, and it's going to show you something quite fascinating. As some time passes, the cold water, a little bit of the gas has come out. In the room temperature, more, and in the hot water, a lot of it has come out. Okay? If you want to do something really bad to your younger sibling, then the Coke bottle that they bought for themselves to drink with dinner, go up to it while they're not looking and open it up, put the cap down, and then stick it in the microwave. Now put the cap back in really, really tight and give it back and put it back in the refrigerator. All sorts of fun things will happen. What will happen? No, in the microwave, no. As you warm up the Coke, what's going to happen to all the gas that's in the Coke? It's going to go flat. So he'll open it up thinking, oh, brand new Coke, and it's cold. It's going to be so refreshing, and it will be flat. Why is it foolish to go fishing in the heat of the day, Matthew? Not enough oxygen. The fish are going to have to go deeper. Now, can you cast well, Matthew? Because if you're a good caster, then what you can do is you can go under where tree limbs are. Yeah, because there the water will be cooler under the shadow. So you could get away with going fishing during the heat of the day as long as you don't mind casting into the shore near where trees are overhanging. How is gas solubility affected by air pressure? Well, it increases it. That's how they make Coke. You see, what makes Coke so refreshing are the little bubbles that are in there. The colder the Coke, the more in the drink are going to be found little bubbles. And as soon as you put that cold drink into your mouth, the little bubbles experience a huge change in temperature, and then the little bubbles are not comfortable anymore in the Coke, so they must come out. So they come out in your mouth. That's why whenever you take a swig of Coke, then what happens is if you could look at your mouth with a camera, you would see bunches of little bubbles. Those little bubbles are what it's normally inside the Coke and are now coming out because your mouth is so hot. Yes. If you had a cold mouth, then less of it would do that. It would probably more likely to happen in your throat. And you would probably burp more too. Okay, the taste really should not be affecting anything. It should be whether it would taste colder or not. You see, one of the prototypical science fair projects is to take Coke that has been left out at for different periods of time. In other words, different levels of flat Coke. And what they do is they give people little cups and they ask them to rate the Coke from warmest to coldest. Now, the key thing is that the Coke is all going to be the same temperature. Every one of them is going to have the same temperature. But when somebody takes a cup with the Coke that is completely flat, that has no carbon dioxide in it, they take a drink, they're going to go, ooh, that's warm because it is the little bubbles that make you feel cold, your mouth feel cold. And of course, when they get to the cup that is freshly poured, they're going to say, oh, yeah, that's the coldest one. That is the coldest one. When in reality, they were all the same temperature. It's your perception. The more little bubbles you have, the colder it appears to be to your mouth. When in reality, it's all the same temperature. So, why is it so important that Coke have little bubbles in them? Because it's what makes it taste refreshing, what makes it feel cold. Even if the Coke isn't cold, it feels cold. So, what do? They make the Coke, and the last thing they do before they bottle it is they insert this tube that's connected to a carbon dioxide tank. And that tube is going to bubble an enormous amount of carbon dioxide into the Coke. And then they seal it up really fast. Why? Because they want to keep those bubbles in there. And if they don't, then it's going to taste flat. So the Coca-Cola company is going to make sure that they shove a bunch of carbon dioxide in there. By the way, do you know the story of Coca-Cola? Started back in the mid to late 1800s. I think it was like 1870 something. It was three partners. They went in together and invested in this idea, shoving a bunch of carbon dioxide into flavored water with a little pinch of cocaine. And they realized, wow, people really like this. Very refreshing, very exciting drink. And to top it all off, people keep wanting more and more and more. So it took them a while, but they finally figured out, oh, yeah, this is not a good idea. Let's stop putting the cocaine in. Thus, Coca-Cola came from cocaine. So yes, at its beginning, they used to put teeny tiny amounts of cocaine in the Coca-Cola. And then no longer, I'm sorry to say for you, no longer do they have cocaine in the Coca-Cola. But remember, I told you there were three partners that came in. They had a fight. So around the turn of the century, they had a fight and decided to split the company in three. One owner kept the name Coca-Cola. The other owner, Pepsi Cola, and the final owner, nope, Dr. Pepper is actually about as old as I am. Royal Crown Cola. You probably know it as RC. RC Cola. I don't know what happened with them. Maybe it was the name Royal Crown Cola. But yeah, you think that it's an off-brand when in reality it's not. It used to be one of the top three. So most of the time, water does not like to have gases inside. So what you have to do is you have to press. Notice that the more air you press onto it, the more you can get inside of it. That is why when you open your Coke bottle, your Coke can for lunch, you're going to hear a. That's all that air that they shoved in there in order to cause the carbon dioxide to be shoved in the water. And it's the carbon dioxide that you guys like. It's the fizz. So, how do water animals breathe? They extract. They don't come up to the surface and take a good gulp of air. They extract tiny oxygen bubbles from the water. Whales are air breathers. Fish, whales, and dolphins are air breathers. What are three ways in which oxygen bubbles dissolve in water? They dissolve directly from the air above the water, Number two, aeration, when water plunges over a dam or flows across boulders in streams, forming a froth. And number three, some plants and animal life produce oxygen through photosynthesis. Matthew, do you like trout? Ever had trout? Yeah, the fish. Trout good? Trout is like one of the best fish. Uh, it's a little more expensive because typically where is the only place you can go find it? Yeah. Okay, what does it tell you about every fish? Unlike humans, humans all need the same amount of oxygen. Fish do not all need the same amount of oxygen. Trout need a lot or a little bit of oxygen. A lot of oxygen. So you're only going to be able to find trout in mountain streams and near dams. Why is it that you can only find it near mountain streams or here in the valley where the water is much warmer near dams? Does anyone know? No, the dams are going to be warm water. Trout need cold water because cold water is going to have a lot of oxygen in it. So how can you get trout to live near warm water? Yes, Chris. More oxygen. That's right. It has to do with this one. There are several ways in which you can get oxygen into the water. You can cool down the water. That's one way, in which case the oxygen will come in straight from the air. Or what you can do is you can get the water to lap over the air and capture the air. So what happens in dams? Ever gone to Norris Dam and see it working? What do you see? Tons and tons of water going through the air and landing down here. What does that mean about the oxygen content down here near the dam? So the trout, what happens is fishermen come and they stock the area down here with lots of little baby trout in hopes that 6 months later they can come and harvest them. The trout can't move too far away from that dam. They have to be near the dam. Too far away from the dam, they start suffocating. So that is why you can find trout near dams. There are also these things called trout farms. Trout farms. These are places down here in the valley where the water is not cold, and yet you can go to usually, typically, it's a man-made trout, a man-made pond, and you can go fishing for trout. There used to be one over here near the I-75, I-40 split. It was called the cross-eyed cricket. And you could go there, you could fish, you can catch the trout, they would clean it and serve it to you. Okay? What was in the middle of that pond? What has to be in the middle of that pond? A sprinkler. Shooting water up into the air as the water comes down, what is it going to capture? Oxygen. A student of mine was telling me, a student last period was telling me, because she's a shark expert, was telling me that the biggest difference between sharks and fish is that these fish have a muscle that allows them to open and close their flaps, which allows water to come in and shoot out their flaps. Apparently, sharks have only those gills on there. So they don't have that muscle that causes it to open and close and allowing water to come in. So that's why sharks have to keep moving in order to breathe.
lamellae. Blood flowing through the lamella takes oxygen from the water and releases carbon dioxide into the water. After the fish receives its oxygen, the water passes out through the gill openings, and the breathing process begins again.
Yeah, they have to keep moving or else they can't breathe. Besides animals, and yes, sir. Yeah, they'll die if you keep them like that for long enough. Besides animals, what other forms of life use oxygen? Bacteria. They're called aerobic bacteria. Have you heard of the type of exercise called aerobics? All that means is you get your heart rate up, you start breathing a lot. So if you're using up a lot of oxygen, you're taking in a lot of oxygen to burn fuel, that's aerobic. I believe in anaerobic exercise. That's where you sit and read a book and you don't use a lot of oxygen. Okay? Aerobic bacteria require oxygen. So what happens if you start feeding the aerobic bacteria lots and lots of food? What will they use a lot of? Oxygen. So this is what could be very, very dangerous. A lot of times what we do, have you ever, next time you go to, you're washing your dishes, look at the label on your dish washing soap. It'll say phosphate free, phosphate free. The reason is that back in the 1970s, we discovered that you could put these phosphates, PO4s, in the dishwashing soap and it would work just a whole lot better. But those phosphates would go into the water and eventually find its way into rivers and streams. And then the aerobic bacteria went to town, eating it. The phosphate was food for aerobic bacteria. So they would use up all the oxygen in the water, and then you had a bunch of fish die. So the first thing they discovered was that fish were dying. And then when they were able to finally figure out what caused the fish to die, they were able to figure out that it was the fact that there was too much bacteria in the water. But it wasn't that the bacteria was infecting the fish. It was that the bacteria was using up all the oxygen in the fish. I'm sorry, using up all the oxygen in the water, allowing the fish to suffocate. So they were dying because we were giving the bacteria too much food. So what happens to the rate of speed of many chemical reactions with every 10-degree temperature change? It doubles. That's important to us in chemistry, but that's also important in life, because that is why, once again, there's 2 windows of time that Matthew has to go fishing and to fish efficiently. What are those 2 windows of time, Matthew? In the evening, yeah, not in nighttime, in the evening, late in the afternoon, early evening, and then in the morning. Right, exactly. Why? Because fish are ectotherms. They're cold-blooded. In other words, they get their body temperature from the environment. We are endotherms. We create our own energy. But ectotherms depend on the environment around them. So what happens if the water gets warm? Ooh, warm water. What does the fish want to do? No. If the water gets warm, they get excited. They want to do stuff. Unfortunately, when they go to do stuff, why? They can't breathe. Unfortunately, in the middle of the night, when the water's cold, the fish are sitting around going, I don't want to do anything. Do you want to do it? No, I don't want to do anything. Do you want to do anything? I don't want to do anything. Why? Is there oxygen in the water? Yes, there's plenty of oxygen in the water, but the water is cold, so they don't want to do anything. So what are the 2 sweet spots, Matthew, again? In the morning when the water is warming up, So you still have plenty of oxygen, but the water is now warm enough for them to go and do their thing. And in the evening, when the oxygen levels are coming back up and they have a lot of energy. What is another type of animal that are ectotherms like that? Snakes, reptiles, which reminds me, of course, South Florida is hoping for a nasty winter. Okay, it's their only hope. Back when I was a kid, we used to have some nasty winters. And what I mean by nasty is like every once in a while, the temperature would get down into the 40s and maybe stay in the 50s for a while. Why are they hoping for a nasty winter? They don't have a snake problem. They don't have an alligator problem. No, they don't have crocodiles. That's a South America, Africa thing, Australia thing. They have iguanas. When I was a kid growing up in Miami, the only place you could see an iguana is by going to a reptile museum or a zoo. Now you can't step without stepping on iguana poop. Iguanas have taken over South Florida. Not only that, the Florida government has given permission for people to go hunting for iguana in your own property. So you see an iguana, kill it, kill it. Now the problem with iguanas in the wintertime, if it gets cold, they're warning people. If you're walking under a tree, be very, very careful. Why do they warn South Floridians to be very careful while walking under trees? Because no, iguanas are ectotherms. No. I'm talking about they warn you about walking under a tree when it gets cold. Think about it. Iguanas are ectotherms, cold-blooded. So when it gets cold, they get very still, very listless. And sometimes they even faint. So they're on a tree, holding on to a tree limb. This has happened. People have gone in the hospital because of this. So you've got an iguana holding on to a tree, going. Finally, it gets so cold that the iguana goes into hibernation. So eyes roll up and people got hit in the head with falling iguanas. Ended up in the hospital with concussions. The iguanas do die. Okay, the reason why historically we've not had iguanas in South Florida is because historically we've had very cold winters. About 20 years ago, two things happened at the same time. Because of climate change, the winters in South Florida got warmer, and people found iguanas in South America, decided it would be cool to keep them in South Florida, kept them as pets until they got to be really big and ugly, and then let them go. So historically, iguanas have not been able to live in South Florida because it was just too cold. That's why they can't live here. They would die. What? They live in Cuba. They live in Mexico. What? Oh, they look like little dinosaurs with spines down their back and just.
It's like a chameleon.
Once we're done, I'll show you a picture.
Is it chameleon?
No, okay. They look like a little bit like a bearded dragon, just much, much bigger. They get to be this big. I mean, they are this big. Okay, so just one more funny story, has nothing to do with ectotherms, has everything to do with things that climb up on trees. My brother, this is one of my favorite, the craziest things happened to my brother. He's 8 years younger than me. So about 20 years ago, he and his wife were living in a condo, And in Florida, the condos are 2 stories and they're right next to each other. It's not, they don't go up, they go side to side. So basically, he was living in a neighborhood with maybe hundreds of condos, which means there's thousands of people living in the neighborhood, and your condo is up against the other one. You share walls, and everyone gets a tree. There's like a tree in everyone's front yard, which isn't much. He typically has to cut his. At that time, he could cut his grass with a pair of scissors. There's just not much to it. So one day, this is back when they used to have, everyone had a Bluetooth device that looked like a little nut that you stick in your ear. So one day, he puts his Bluetooth device, goes out his front door and into the sidewalk, and then his Bluetooth device falls down. So he's looking all over the place, and then he sees this little gray blur just run past where he was. And he goes and he looks, and there's a squirrel going up his tree. And the squirrel has something funny in his mouth. And he realizes that he dropped his Bluetooth device. The squirrel thought it was something that it could eat, grabbed it, ran up the tree. So now there is a squirrel up his tree with a Bluetooth device in its hand. So of course my brother starts to throw rocks at the squirrel. The squirrel won't let go of his Bluetooth. So he decides to do what any red-blooded American male does. Goes back into his house, takes out his rifle. So now he is trying to shoot the squirrel with it was his pellet gun. He does have a rifle, but this one was his pellet gun. So he liked to go shooting, with his friends with pellets. So he's there trying to kill the squirrel with a pellet gun. The squirrel is running from tree to tree. My brother is getting frustrated. So he is following the squirrel in the middle of Miami with a pellet gun, aiming it at trees. Within minutes, 2 squad cars converge on where he's at from 2 different directions. Sir, drop the gun now. There's a squirrel. Drop the gun now. But sir, there's a squirrel with my Bluetooth. Sir, and now he realizes there are now 2 guns aimed at him. So he carefully drops his pellet gun. They go, they grab a hold of his gun, and they're going, "What are you doing?" And he's pointing at the tree, where now there's a squirrel gnawing at his Bluetooth device and probably laughing hysterically at my brother. So after the cops had a good laugh along with him, no, my brother wasn't laughing, along with the squirrel, they made my brother put his pellet gun back up and just realize that he should be lucky that he's not arrested right now. So that is one of my favorite brother stories. What happens to fish when water temperature increases? They get more active. Yes, that was a completely free story. Usually all my stories have a chemistry reason. That was not. That was just free. That was just funny. What happens to fish when water temperature decreases? They get more sluggish. I think Deo over here is an ectotherm. I think I need to warm up the room so that he gets more active, because I think he's asleep. What happens when they get more active? They want to eat more. And if they're eating more, they need more oxygen. And therein is the problem. That's why he could not get any fish in the middle of the day. Was it warm enough for the fish to go after his lure? Yes. But whenever the fish would go after that lure, what would it start to do? Suffocate. And he would have to go back deep in order to be able to breathe again. So it'd be like, and then he would have to swim back in order to breathe again. So what happens to during the summer months to these fish? If the water gets warm enough, it could kill them. They could be there's a limited amount of oxygen, lots of fish. They're fighting for the oxygen now. They're not fighting for food, they are fighting for oxygen. There's plenty of food in the summertime. They fight for oxygen. During the wintertime, you might have more luck going during the heat of the day because even during the heat of the day, it's still cold. So they're fighting for food during the wintertime, so they're more likely. But who wants to go fishing when it's cold outside? Not I, said the fly. What happens during long stretches of hot days in the summer? We call them fish kills. You might see fish just floating on top. They suffocated. Fish that jump out of the water. There's probably some kind of bug and they just jump to.
No, like what are they called? Like you see them fly out, just jump out.
Well, in South Florida, if you go out in the ocean, you will encounter flying fish. Okay. But here in East Tennessee, they're just fish who are trying to catch a bug. Bugs, yes. Fish live on bugs too. How do manufacturing power plants disturb this delicate balance? The EPA do not like, not the EPA, environmentalists do not like nuclear power plants. You know why? You see, in order to cool down the nuclear power plant, they suck up water from the river or lake. That's why you will always find a nuclear power plant, like the closest one is in Watts Bar. You'll find it near a river or lake or the ocean because they suck in the water in order to cool down the plant. Now, do you think that the environmentalists get mad because the water that they bring back out is full of nuclear waste? No. No, the water that they suck in, that they use, they have to super clean. So the water that comes back into the river is super clean water. That's not their problem, even though some of them do want and complain about the water being too clean, that the power plant removes all the nutrients out of the water. But these people have to complain about something. What do you think they complain about? No. What did I say? What did they use the water for? To cool down the power plant. So the water coming out will be warm, not hot, but warm enough to not have the oxygen. So they often take in cool water to cool their plant and return much warmer water. All right, for you fishermen, here it is. Trout needs it to be around 59 degrees. So if you're going to go trout fishing, either you're going to have to go fishing near the dam or you're going to have to get really cold water. Perch or pike, 75. Catfish and carp, 90. In the 90s. That's why you go to Broadway on the beach, on Myrtle Beach, you know what I'm talking about, that huge shopping center. What's in all that water? Carp. Nasty looking fish. They look nasty. Okay, how can they survive that since that water's not moving? They don't need a lot of oxygen. Yeah, they do. You don't eat carp. Carp and catfish are both scavenger fish. That means they'll eat whatever. You might like catfish, but catfish is scavengers. Now, do you know the relation? Listen, one more thing. This is interesting. You know how some fish meat is red and then cooks red, and then some fish meat cooks white? That has to do with how much oxygen is in the meat. Catfish, because they don't need a lot of oxygen, will turn white. Things like salmon and trout, their flesh is a reddish pink color because their flesh has a lot of oxygen. Now, let's connect that to chicken. Dark meat, white meat. Where does the white meat come from? The white meat comes from the chest, right? The breast, the thighs that are not going to be, it's going to be made up of muscle that gets to be used a lot or not a lot. Think about the muscles that you have here on your chest and your belly. Do you use it a lot? as compared to the muscles that you have on your arms and legs? No. So the muscles that have a lot of oxygen in them are going to have a dark consistency. The muscles that do not have a lot of oxygen in them are going to appear white. That is why the breast on chicken, the thighs, white meat. What's going to be dark? The wings and the legs. So now you know